Hi everyone. The second record lecture about the chapter 3. I will start it from we have two mechanisms for the nucleophilic substitution reaction. The first mechanism is SN2 mechanism. SN2 meaning substitution nucleophilic bimolecular, and SN1 mechanism substitution nucleophilic unimolecular. And we will know what is the difference between of them. The first one, the SN2 mechanism, and if you can see it here, we have methyl bromide and we have the acetate, and the acetate with negative charge on the oxygen atom. That meaning is nucleophile. And we will, overall the reaction, we replace the Br with this nucleophilic group. And to give you the ester compound, this ester functional group. Then, what meaning SN2 exactly? An SN2 reaction exhibits second order kinetics. Second order kinetics is that is the reaction is bimolecular. What meaning bimolecular? What meaning second order reaction? Meaning both the alkyl halide and the nucleophile appear in the rate of reaction. That meaning the concentration of both the starting material and nucleophile can be effect on the rate of the reaction. Okay, if we go back again to here, that meaning if you increase the concentration of the alkyl halide, also the concentration of the nucleophile, that meaning the rate of reaction, it will be increase. Increase the concentration, the rate of reaction will be increase. Okay, this is the meaning. That meaning we can control our reaction by concentration, or by controlling the concentration of both the alkyl halide and the nucleophile. And he said here we have the rate of reaction equal to the constant equilibrium concentration of the alkyl halide and the concentration of the nucleophile. Okay, and the mechanism of SN2 mechanism is just one step. That meaning the nucleophile, look, the nucleophile, the negative charge, the unshaped of electron, it will be attack the carbon. Okay, attack the carbon. The carbon here is partially positive. Why? Because we have brom, and the brom atom is high electronegativity atom. It will be partially negative. That meaning the negative, it will be attack the partially positive, not attack the negative, the partially negative. Okay, negative attack the positive, and then the brom, it will be go out as leaving group. Leaving group, the brom minus is stable leaving group, good leaving group. Okay, why? Because it's stable part. And we have here a new bond, a new carbon oxygen bond, a new sigma bond. And here we'll talk about the stereochemistry of the SN interaction. We know the stereochemistry is the arrangement of the atom in the space. And he said here, from what direction does the nucleophilic approach the substrate in the SN2 reaction? From any side, the nucleophile, it will be attack the substrate. This is the substrate. Okay, the alkyl halide. Substrate meaning here the alkyl halide. Okay. That meaning it will be go from the front side or from the back side. Okay, and there are two possibilities for the attraction. We here front side attack. The nucleophile approach from the same side as a leaving group. Okay, that meaning the nucleophile, it will be attacked from the same side for the leaving group. And we have back side attack. The nucleophile, it will be from here, from the back side. The nucleophile approaches from the side opposite to the leaving group. If the leaving group from this side, from the right side, the nucleophile will be attacked from the left side. Okay, and in front side attack, the nucleophile approaches from the same side as the leaving group, forming compound A. and because the nucleophile and the leaving group are in the same position relative to the other three groups, that meaning the halogen from this side, okay, and also the nucleophile, it will be from this side related with this three group, okay, the other three group on the carbon. Frontside attack result in the retention of configuration. That meaning the configuration of this, we know what meaning the configuration. The configuration of this compound, it will be the same, no different. Look, hydrogen in the backside, CH3 here near from you, and the deuterium in the down, it will be remain the same thing. Hydrogen in the backside, the CH3 from here, and the deuterium in the down. That meaning the configuration, it will be the same, okay. And in the attack from the back side, the nucleophile approach from the opposite side to the leaving group. Look, the leaving group here, and the right side, the nucleophile will be go from the back, okay, forming the compound B. And because the nucleophile and the leaving group are in the opposite side relative to the other three groups, the backside attack result in the inversion. Inversion طلبة meaning انقلاب, okay, inversion of the configuration. Look, this CH3 from here, from the left side, it will be on the right side. That meaning all this three group, it will be inversion of configuration around the stereogenic center. Stereogenic center meaning the carbon here طلبة. This is the stereogenic center, meaning carbon with 4 different groups. 1, 2, 3, 4. That meaning we have carbon atom with 4 different groups. This, it will be called stereogenic center. Okay. That meaning from the back side, we have inversion of configuration. From the same side, retention of the configuration. And the nucleophile to replace with the Br on the opposite side. Actually, يا طلبة, in the SN2 reaction, all the mechanism, it will be from the back side, and all the SN2, it will be happen inversion of the configuration. Okay, that meaning for the SN2 reaction, there is no retention of a configuration. This is not related with the SN2. Okay, because in the SN2, we know the mechanism, it will be like this. Look, the nucleophile, it will be attacked from the back side, and it will be remove the leaving group. And the product of front side and back side attack are different compound. Look, this is different compound, and طبعا different compound, not about the name of the compound, the same name of the compound, but about the configuration. Okay, A and B are stereoisomers that are non-superimposable. Non-superimposable, that meaning cannot be in the same. If you put this on this, it will be mirror image. This is exactly a mirror image for this. Okay, they are enantiomers. طبعا enantiomers with stereoisomers like this. It is related with the stereochemistry, and maybe the next year we will take this inshallah. But now I want from you to know the SN2 reaction. It will be happen inversion of the configuration, and the configuration for the product, it will be different from the starting material. This is the important thing. Now, which product is formed in an SN2 reaction? When the stereochemistry of the product is determined, only B, the product of the backside attack, is formed. Look, this طلبة is very important. For the SN2 reaction, just it will be from the backside. Okay, only this compound, it will be formed. There is no this compound. Okay, only this compound. Okay, if we have reaction for the SN2 reaction, the product, it will be just B. There is no A. It will be not formed. Okay, that meaning all the SN2 reaction will be happened from the backside attraction and give you inversion of the configuration. All the SN2 reaction proceed with the backside attack from the nucleophile, resulting in inversion of the configuration at stereogenic center. This is very important. Look, we have nucleophile from the back side, and the leaving group it will be go, and we have transition state. Transition state, that meaning we have a new bond here, and we have a broke down bond from between the carbon and the halogen. Okay, this is a transition state, meaning حالة انتقالية. Transition state, and give you the product. Just one step. Look to this reaction, one step. Okay, don't say this one step two, not two step. This transition state يعني طلب حالة انتقالية. It is not really compound. Okay, we cannot separate this compound alone. Okay, it will be just a transition state. Look to the carbon here. We have a 3 sigma bond, and we have here dot bonds. This not really bond here. This it will be a new bond, and this bond it will be broken like that. It is just give you explanation how the product it will be formed from the SN2 reaction. Look, we have the SH negative group as a nucleophile to be attacked from the backside, and the halogen it will be go out and give you inversion of the configuration. Look, we have inversion يعني انقلاب في structure inversion. And we have the hydroxyl minus also is strong nucleophile. It will be attack this carbon, the partially positive charge carbon, and with the leaving group, and the leaving group it will be go out to give you alcohol. Inversion of the configuration. The bond in the nucleophile in the product is always in the opposite side relative to the bond to the leaving group in the starting material. Okay, that meaning the bond to the nucleophile, the bond it will be opposite side to the halogen. Okay, that meaning this is the meaning for the inversion of the configuration in the opposite side. The identity of the R group, that meaning the alkyl group on the carbon with the leaving group can be effect of the SN2 reaction or not. As a number of R group, the alkyl group on the carbon طبعا on the carbon with the leaving group increase. Look, increase. This carbon has 3 alkyl group. This carbon has 2 alkyl group. This carbon has 1 alkyl group. Okay, that meaning when the alkyl group on the carbon increase, the rate of the SN2 reaction decrease. That meaning the rate of the SN2 reaction here it will be slow, and here it will be high. High speed of the reaction, here low, the reaction it will be low or slowly. Here the reaction it will be faster, slowly, faster. Why? This طبعا طلبة dependent on the steric effect, الإعاقة الفراغية, the steric effect. If we have here more groups, that meaning the nucleophile it will be difficult to attack this carbon. Okay, because the alkyl group, because the steric effect الإعاقة الفراغية. Here we have just 3 small hydrogen atoms. The nucleophile easy to attack this carbon. Okay, there is more space to attack the carbon. Okay, here there is no space. Space is difficult here because the alkyl group is big groups, and the nucleophile is difficult to enter to this carbon. Okay, to attack this carbon, to remove the leaving group. And the methyl primary, this is the methyl here, undergoes interaction with easy to enter to the SN2 reaction. The primary also easy to enter the SN2 reaction. The secondary alkyl halide is more slowly. Okay, the tertiary, this tertiary طلبة right here don't undergo SN2 reaction. Here there is no SN2 reaction. بالنسبة طلبة very. Here there is no SN2 reaction. Right here, please. For the tertiary alkyl halide, there is no SN2 reaction. Why? Because the steric effect. Because this the steric effect. This order of reactivity can be explained by the steric effect. As a small hydrogen atom are replaced by larger alkyl group, the steric hindrance caused by bulky by bulky R group, that meaning bulky meaning big. R group makes the nucleophilic attack from the backside more difficult. Okay, more difficult, not easy. Here the attack from the backside not easy. Here easy. Here also easy. Here is slowly this into the reaction will be happen, but very slowly here. Okay, and here you will be see the transition step. Here just we have three hydrogen, that meaning this primary alkyl halide is less crowded transition state, lower in energy, that meaning less crowded transition state, that meaning we have a free space here, more space to attack the nucleophile from the backside. Okay, and the transition step, it will be low energy. Low energy, that meaning the reaction it will be easy to give you the product. Here, look, CH3, more crowded, the steric effect is high here. More crowded transition state, higher in energy. That meaning the reaction will be difficult to give you the product, or needed more energy, more time to give you the product here. And you can see here, look, the nucleophile attack from the back side, sorry, and we have 3 hydrogen atom here. Replace the hydrogen with CH3. Look, also easy. We have here space. Look, for the secondary alkyl halide, look to the crowded here carbon, and there is crowded here. That meaning the nucleophile is difficult to enter to this carbon and to make attraction to remove the nucleophile. And for the tertiary alkyl halide, look, it is so difficult to attack from the backside. That meaning for the tertiary alkyl here, there is no SN2 reaction. Increasing the number of alkyl group on the carbon with the leave group, and increase crowding in the transition step, decreasing the rate of the SN2 reaction. This talaba so important. Memorize this. The SN2 reaction is fasted with the unhindered halide. Okay, that meaning with a primary or the methyl halide, or primary on maybe the secondary with unhindered halide. That meaning unhindered halide. That meaning with less substituted group. And here this homework for you: which compound in each pair undergo the faster of the SN2 reaction? Anyone is easy to go to the SN2 reaction. This or this, this or this, this or this. Okay, I think it's easy. Try to resolve this homework. And now the SN1 mechanism. What meaning SN1 mechanism? Here the reaction of the CH3 by 3, that meaning we have 3 CH3 here, with CH3COO minus, this is the nucleophile, is an example for the second mechanism of the annual molecular substitution, the SN1 mechanism. Okay, what meaning this? Meaning the SN1 reaction exhibits first order kinetic, that meaning the rate of reaction just dependent on the concentration. Look, on the concentration of the alkyl halide. This is the concentration of the alkyl halide. That meaning if you increase the concentration of the nucleophile, the rate of reaction, it will be the same. There is no different. But if you increase the concentration of the alkyl halide, the rate of reaction will be increased. This is the meaning here. Okay, طلبة? This is the meaning for the first order kinetic. That meaning the kinetic طلبة الحركية. That meaning the kinetic of reaction just dependent on the concentration for the one component, and the most straightforward explanation for the observed first order kinetic is two-step mechanism. That meaning the best explanation for the SN1 mechanism is with two-step mechanism. Okay, for the SN1 طلبة, just I said the mechanism is just one step. Okay, one step with the transition step. Okay, here in the SN1 mechanism, the mechanism it will be two steps. Okay, two steps, not one steps. Okay, now in which bond breaking occur before bond making. For the first step, what we have? We have bond breaking. Okay, the bond it will be broken. For the next step, the bond it will be formed. Okay, this is so important. Okay. We will take one example. Look this tertiary alkyl halide. Tertiary alkyl halide just undergo SN1 mechanism. There is no SN2 mechanism. Okay, that meaning if you have nucleophile like this, cannot be attacked from the backside. Okay, now what will be happen? The carbon here, the halogen, it will be broken. It will be broken, but heterolytic breakdown. Okay, that meaning the both of the electron it will be go with the leaving group, and we have here carbocation. Carbocation meaning carbon with positive charge. Cation طلبة carb cation. Okay, that meaning, and this carbocation now is stable. Why the carbocation is stable? Because we have 3 alkyl group. The alkyl group is donating group, can make increase the stability of the positive charge. Okay, now look to the heterolysis of the carbon brom bond from the intermediate carbocation to form intermediate carbocation. This step is rate determination because it is involved just one only bond cleavage. This is rate determination step يعني الخطوة المحددة للسرعة. Okay, slow. Always in the reaction we will take the slow steps to determining the rate of the reaction. Okay, the second step, look here, the nucleophile, it will be easy to attack the positive charge, and this step it will be so fast. Why? Because the nucleophile it will be easy to attack the positive charge, and of course carbon with 3 groups, it will be trigonal planar. That meaning the nucleophile it will be easy to come from this side or from the back side because it is a trigonal planar, and there is no any steric effect here, and it will be directly give you the product. This is the best explanation for the SN1 mechanism with 2 steps reaction. Okay, and the key feature of the SN1 mechanism, what is the difference here? The mechanism has 2 steps. Okay, this is the difference from the SN1. SN1 1 step, SN2 sorry 1 step, SN1 2 step. Also, in the SN2 in the SN2 there is no carbocation, but in the SN1 mechanism we have carbocation as intermediate product formed as relative intermediates. Okay, here the difference between the SN1 and SN2. The stereochemistry of the SN1 reaction. Now the stereochemistry. Okay, the stereochemistry of the SN1 reaction. To understand the stereochemistry of the SN1 reaction, we talk about the SN2, and we say the SN2 is habit inversion of the configuration. And here we must examine the geometry of the carbocation. I said the geometry of carbocation, carbon positive charge with 3 groups. It will be trigonal planar. Trigonal, look, this is a trigonal on the one plane. Okay, carbocation with 3 groups around the carbon is sp2 hybridized and a trigonal planar and contain a vacant p orbital. That meaning we have empty p orbital here with positive charge, empty خالي, extend above and below to the plane, above and below. This is the orbital above and up and to down to the plane. Okay, here if you have nucleophile, the nucleophile can be attacked from the down, can be attacked from the up. Okay, from the both of side. Look, if you have nucleophile, and nucleophile is easy to attack from here, is easy to attack from here, and for this reason it will be give you 50 for the rotation of the configuration, the same configuration, and 50 to the inversion of the configuration. This is the same configuration, that meaning rotation of the configuration. This is different configuration, that meaning is inversion of the configuration. 50 to 50. Okay, 50 to 50, half to half. Said here because there is no preference for the nucleophilic attack from either direction. That meaning the nucleophile it will be easy to attack from here or from here. Okay, this 2 direction, an equal amount of the 2 enantiomers is formed as racemic mixture. طلب racemic mixture meaning 50 to 50, 50 enantiomers, 50 to the second enantiomers. Okay, we say that racemization has occurred. Racemization is the formation of equal amount of the two enantiomeretic product from the single starting material. We have one starting material and give you two product. Okay, two product. طلبة the same name, just we say the stereochemistry is different, the configuration. Okay. And the SN1 reaction proceed with racemization at single stereogenic center. Okay, here the racemization, that meaning racemic mixture 50 to 50. And after nucleophilic, it will be attacked for the carbocation. The compound try to resolve or to remove the positive charge on the oxygen by acid-base reaction to remove the proton and to give you here the product. And here, this homework, draw the products of the SN1 reaction. Look, this SN1. Why SN1? Because the alkyl halide here is tertiary alkyl halide. Tertiary alkyl halide meaning SN1 reaction. And again, the stereochemistry and how the stereochemistry for the stereogenic center for this carbon. Okay, try to resolve this question for you. And here the identity of the R group. Okay, here more R group, that meaning the rate of reaction it will be increase. Okay, reverse to the SN2 بالعكس عكس بالضبط. Okay, more R group, the rate of reaction will be decrease. Here no, more R group, the SN1 reaction it will be increase. Why? Dependent on the stability of the carbocation. Okay, dependent on the stability of the carbocation, you can write here, right? Dependent on the stability of the carbocation. Okay. Why the carbocation? More R group, that meaning it will be the positive charge, it will be more stable on the carbon. Here, tertiary alkyl halide undergo SN1 reaction rapidly. Okay. The secondary alkyl halide react more slowly with SN2 reaction. Methyl and the primary alkyl halide don't undergo SN1 reaction. It will be go to the SN2 reaction. There is no SN1 reaction for this طلبة, and for this there is no SN1, just SN2. For this, maybe both of them, SN1 and SN2. Here, no, just SN1, there is no SN2 reaction. Carbocation stability, طلبة here, carbocation stability, and look to this, methyl, positive charge, and here, primary carbocation, secondary carbocation, tertiary carbocation. Carbocation are classified as a primary, secondary, and tertiary by the number of R group bonded to the charged carbon atom. As a number of alkyl group on the positively charged carbon atom increase, the stability of the carbocation increase. That meaning more R group, the positive charge here, it will be more stable. Okay, more stable. Less alkyl group, this carbocation, it will be less stable, depending on the stability of the positive charge on the carbon. And here he said classify each carbocation as a primary, secondary, tertiary. This carbocation, what? Primary, secondary, tertiary, and this. And draw the structure of primary, secondary, tertiary carbocation, each having molecular formula C4H9 positive. Okay, positive. I want to draw primary, secondary, and tertiary carbocation for this chemical formula with positive charge. Positive charge on the carbon atom. Rank the carbocation and then rank the three carbocation in order and increase the stability. Put of them according to the increase stability or decrease the stability. Okay. Anyone it will be more stability, anyone it will be less stability. This طلبة good question. And please try to resolve this question. This is so important question طلبة. And here we will examine the reason for this order of stability by invoking two different principles: inductive effect and how the carbocation طلبة will be stable by using inductive effect and the hyper conjugation effect. Okay, what meaning inductive effect and what meaning hyper conjugation effect? Inductive effect, I think we take it before that in the introduction part, yeah. And the inductive effect here are electronic effect that occur through sigma bond, okay, through sigma bond. Alkyl group are electron donor. Donor meaning it will be give, okay, giving, donor. Donor groups that stabilize the positive charge. An alkyl group with similar sigma bond is more polarizable than the hydrogen atom. More polarizable than the hydrogen atom and more able to donate the electron density. Okay, more able to donate the electron density. And for this reason, as R group successfully replaced to the hydrogen atom in the CH3, the positive charge will be more displaced on the carbon, on the electron donor groups or the R groups, and the carbocation will be more stable. Look at this one, R group donating. This there is no electron. It will be donate electron by inductive effect. This it will be less positive charge. Less positive charge, that meaning more stable. Here we have two alkyl group donating, that means this more stable. Here we have three alkyl group donating, that means it will be more stable. Okay, an increased number of the electron donating R groups increase the carbocation stability. And here the second explanation for the how the alkyl group it will be increase the positive charge on the carbon atom. Here we said with hyperconjugation. This the second explanation for the observed trend of the carbocation stability is based on the orbital overlap. Okay, look, what meaning overlap? If you have here positive charge empty orbital and you have here near alkyl group like this CH3, the positive charge here it will be slightly disappeared, delocalized with the hydrogen with overlapping of the orbitals here, with the overlapping of the orbitals. And also you have three hydrogen atom here, and all of them it will be overlap with the positive charge, and slightly it will be increase the stability for this carbocation. And here for the tertiary carbocation is more stable than secondary and primary or the methyl vehicle because the positive charge is delocalized over more than one atom. Okay, here the explanation exactly. And here separating out charge by overlap of an empty p orbital with an adjacent sigma bond is called hyperconjugation. Hyperconjugation, that meaning we have overlapping between two neighboring carbon with the carbon, neighboring carbon, and we have overlap between of the p orbitals. And here the rate of SN1 reaction increase as a number of R group on the carbon with the leaving group increase. Okay, this is also so important. The stability of the carbocation increase as a number of R group on the positively charged of the carbon increase for the carbocation. And this طلب homework for you, which is likely mechanism for the nucleophilic substitution for the alkyl. Okay, you have here many alkyl halide. Anyone it will be go to the SN1 or SN2. This SN1 or SN2, and this SN1 or SN2, this SN1 or SN2, and this is SN1 or SN2. Okay, any mechanism it will be best for this compound to enter to the nucleophilic substitution reaction. And here characteristics of the SN1 SN2 mechanism. طلبة أو ملخص. Okay, this is so important. The kinetic here for the SN2 mechanism, the kinetic is second order kinetic. Okay, look to the kinetic here, first order kinetic. The mechanism just one step, the mechanism here two step. The stereochemistry, backside attack of the nucleophile, inversion of the configuration at the stereogenic center. Here, trigonal planar carbocation, intermediate, and give you racemic mixture. Racemic mixture for the 50 retention of configuration and 50 inversion of the configuration. For the allyl group, unhindered halide react fast. Here, more substituted halide react fast. Okay. The rate of reaction will be primary, secondary, tertiary, and like this. The rate of reaction will be reversed. Tertiary, secondary, primary, and reverse to the SN2 mechanism. This ملخص طلبة. Okay, abstract for the SN1 and SN2 reaction. This is so important to help you to memorize the features and the properties for the SN1 and SN2 mechanism. And this chapter is already finished, and I hope you understand this chapter. And also please try to resolve your homework by yourself by using paper and pen طلبة. And also if you have any question, we can make meeting together on the model. And again, study hard. Have a good day. See you later inshallah. Bye bye.